Hi, and welcome to the Biostatistics for the Rest of Us channel. Today we're going to be talking about measures of central tendency, and we're going to do this by solving a particular example. So we have this example. It says the hemoglobin concentration in grams per dl of individuals in a sample of primary school students during a school health program in a primary school in Kaduna State was as follows. 12 children had a HB concentration of 9.0 to 9.9. 7 children had 13.0 to 13.9. 16 children had 10.0 to 10.9. 3 children had 11.0 to 11.9. 8 children had 12.0 to 12.9. And 20 children had a hemoglobin concentration of 8.0 to 8.9. So we're expected here to calculate the measures of central tendency of the data. Alright, easy peasy, lemon squeezy. So looking at this example here, let's just put out all the information that we're given, and we'll try to arrange this in order. Okay. All right, I guess that's all we have. So when we say central tendency, what do we mean? The question is asking us to compute the measures of central tendency, and the most important one we'll be talking about here is the mean, the median, and then the mode. Okay, so the mean, the median, and the mode. All right. So the next thing we'll need to do is to put this data that we have in a table. I'll just quickly draw up a table. Oh, I think this is too big. All right. So with this table, we will first use the first column as the HB level, and this is in grams per dl. Always remember to put your unit. Okay, the groups first, and then we'll put each corresponding frequencies. The first frequency is 20, the next is 12, and then 16, and then we have 3, we have 8, and we have 7. Awesome. All right, the next thing we'll need to do is to compute the mean, and the mean goes by this formula: summation of f times x divided by summation of x. All right. So usually when you see summation, when you see this symbol, it means summation. So the next thing you see here is summation of f in the denominator. All right. So on this summation of f, meaning we'll just add all the frequencies together. So it's sum of all the frequencies, and then summation of f by x. So when we multiply f times x, we would now sum all the individual values together. That's what this means. But the question here is, what is this x? So this x we're trying to talk about here is the midpoint. So it's the midpoint of the classes. So what we will do is to first start with the frequencies. Since we have all the frequencies, we would want to compute the summation of the frequencies. So we're just going to add all these values together. 3, 8, 7, and then what we'll get here is 66. All right, so there are actually 66 individuals. Okay, let's just put the 66 there. Okay, so we have all the frequencies, and we've added all of them, so we have 66. So we'll just put the 66 there, and then it's worthy of note that we can easily just compute the cumulative frequency, because we're going to need it for computing the median. Okay, so let's just compute this cumulative frequency. If we remember how cumulative frequency is being computed, what we'll be doing is we will be first starting with the first frequency, and then we would add the next frequency to it to give us the cumulative frequency for that class. So here we'll say 20 plus 12, that will give us 32, and then we'll add 32 plus 16, that will give us 48, and then we'll add 3 to 48, we'll have 51, and so on and so forth. All right. Now, one thing you need to note is that the last cumulative frequency should be the same thing as the total number of individuals that we have. All right. It should be the same thing as the total number of individuals that you have. So by the time you get to the last class, which is the class of 13 to 13.9, that's the last group. All right. The cumulative frequency you should have there should be the same thing as the total frequency. All right. This is a check. You have to always make sure you're correct on this level. All right. So the next thing is, what is this x that we've all been talking about? Well, this x is the mid value, and it's just the midpoint between the lower limit and the upper limit, all right, of a particular class. Okay, so we're just going to use this first class to see the mid value here. So we're going to say 8 plus 8.9, and we're going to divide by 2, and that will give us 16.9 over 2, and that's 8.45. Awesome. I think we're doing great. So if this is 8.45, then this will be 9.45, 10.45, 11.45, 12.45, 13.45. Please, if you are doing an exam or a test, make sure you put in all your calculations. Make sure you show all your calculations, right? Make sure you show all your calculations one by one, and each calculation point would score some marks. So just don't put in the figures there. Make sure you quickly put in the calculations, and that means you need to be very fast when you're doing this. Okay, so the next thing we want to do now is to multiply the frequency by the midpoint. That's the fx. All right, so we want to do that for each of those values. So if we start from the first one, our first frequency here is 20, and then we'll be multiplying 20 by 8.45. that's the first midpoint, and we're going to be getting 169.0. all right, so we will do that for all the other values, and like I said, please show your calculation for all of them. I've already done these calculations beforehand, and I'm putting them out here to save time. Okay, and then so now remember, for our formula we need to get summation of f times x, right? Summation fx, all right, ef of x. All right, so we're going to need to add all of this together. All right, this time I'm going to show the calculation. We're going to add 169 plus 113.4 plus 167.2 plus 34.4 plus 99.6 plus 94.2, and then we're going to be getting when you're hitting on your calculator, you're going to be getting 677.8. Awesome. I think we're doing really well. So we have all the values that we need. We have the sum of ef, which is our total frequency, and that's 66. We have our ef of x, which is our numerator, and that's 677.8. so all we need to do is to plug all of this into the formula. So remember, our formula mean is equals to ef of x divided by summation of the frequencies, right? So we're going to be doing 677.8 divided by 66, and then we'll be getting our mean to be 10.26 gram per DL. This is awesome. This makes a lot of sense. Let's keep this, and then let's move to the next one. Remember, we want to be computing the median next, since we're doing measures of central tendency. All right, so the median goes by this formula, very beautiful formula. Make sure, please, you know the formula. Make sure you're writing the formulas down correctly. All right, because each formula that you write down is going to have a score, it's going to have a mark if you're preparing for exams or if you are doing a test. So make sure you write the formula down. Then even after writing the formula down, you need to explain every symbol in the formula. So we're going to be explaining the first one. The first one here is denoted by a small letter L, all right, and this is the true lower limit of the median class. Now, everything about this formula is mainly related to the median class, and you need to first find out the median class. That's the first thing you need to do. So here there are differences of opinion among the scholars depending on the kind of data that you have, but most often than not, to be on the safe side, I advise you to use the true lower limit of the median class. That's the lower class boundary. All right, you'll be seeing some other scholars maybe online using the lower limit. No, but the correct thing to use is the true lower limit, and that is the same thing as the lower class boundary. Okay, I hope this is clear. All right, then we'll talk about the next one, which is the H. H here is the width of the median class. Everything relates to the median class as much as possible. And the F that we have here is the frequency of the median class. And so our N is the summation of the frequency, which is the total number of individuals. And the C that you have here is the cumulative frequency of the class before the median class. So if you have a class before the median class, the cumulative frequency of that class. Now, if you're able to write down the formula correctly and are able to identify all the different parts of the formula, then you're already well on your way to success. All right. So the most important thing is to get the formula correctly and then write out what each of the symbols in the formula mean, and then try to piece that out from the table. Remember, when you're also drawing tables, please, your tables must be well labeled. Put the title of the table at the top. Label all the tables properly. In the areas where you need to put in your units, please put in your units. So L, like I said, is the true lower limit or the lower class boundary, and you need to please put that in mind. All right, so let's put up this table again very quickly. And now what we'll be doing is, with the formula, we already know different parts of the formula. We just need to piece that out from the table. The first thing we'll need to do is to find out the N. The N is equals to summation F, and when we check it in our table is 66. The next is to do N over 2. Yeah, so listen carefully here, guys. Now we are looking for the median class. In order to find the median class, all right, we have to first do our N over 2, which we have done, and we've gotten 33. The next thing is that we need to look for the cumulative frequency that is just above this our N over 2. All right, so we're looking for the cumulative frequency that is just above 33, and if we check, we're going to see that that cumulative frequency is 48. So our point of call is this entire line, right? This entire row is the one that we will be focusing on. Okay, and the class there is known as our median class, and that class is 10 to 10.9. That means our median value will fall between 10 and 10.9. So our median class is this particular class. So everything we're going to be doing is going to be related to this particular band here, this row. All right, so remember, our L is the true lower limit. So, and to get the lower limit, we have, that's the lower class boundary, right? So we will need to add 10.0 plus 9.9 divided by 2. We'll have 9.95. Just picture it like this. If this first aspect is the space between the preceding class and our main class, all right, our median class, so we know that there's a space between 9.9 and 10.0, right? All right, so our true lower limit is going to be at that junction between both of them. So all you need to do is just to add 9.9 with 10.0 and divide by 2, and you'll be having 9.95. This is really, really very simple, and you don't need to show all of this in the table. Just show your calculation and identify where you got this value. So our true lower limit is going to be 9.95, and we're just going to use that to plug it into the equation. So we have our table again. This is our median formula. Remember, L is equals to 9.95. Our H is the width of the median class. Okay, so we're just going to put that. And how do we do this? We'll just subtract the lower class limit from the upper class limit, and that will give us our H. Our F, which is the frequency of the median class, we can see there is 16. All right, and then our N over 2 is equals to 33, like we've computed before. And then our C, we said, is the cumulative frequency just above the median class. Okay, so with our formula, we're just going to plug all of this into play. So we have our 9.95 as our L, our H is 0.96, divided by our F is 16, and then we'll be putting in 33 and minus C, our C is 32. So by the time we put all of this, we're going to be getting a median of 10.0. Whoa, that's quite close to our mean. Remember, our mean is 10.26. All right, awesome. We're arriving at something here. The last thing we need to find out is the mode, just to complete the measures of central tendency, right? All right, let's do this. So we just have our table again, all our values into the table. All right, now the mode goes by this formula. The mode goes by the formula that you can see here. All right, a very simple formula. L here is the true lower limit of the modal class this time. H is the width of the modal class. F1 is the frequency of the modal class. F0 is the frequency that is preceding the modal class, that's before the modal class. F2 is the frequency after the modal class, and our modal class here is the class that has the highest frequency. So we're just going to look around. Unfortunately enough, the first class is the one that has the highest frequency. That's the frequency of 20, because if we look at all the other frequencies, 20 is the highest, right? So the class of 8 to 8.9 has our modal class. What it means is that our mode is in this class. The mode value is within 8 to 8.9. All right, so fine. So what we will do here is to first compute our L. Remember, our L is the true lower limit of the modal class, and what we want to do here is to make sure we find the true lower limit. All right, so unfortunately there's no class before this our modal class. So but assuming there was a class, all right, the upper limit of that class, right, and the lower limit of our modal class, there's a space between them. All right, in order to find out the true lower limit, we're going to have to add them together. All right, so and the upper limit of the preceding class is going to be, even though there's no preceding class, but if there were, we're going to be having 7.9, right? So it's going to be 7 to 7.9. Okay, so here we're going to be doing that 7.9, we're going to add it with our lower limit of our modal class, and we're going to divide that by 2. So we'll have 7.95. So our L is 7.95. All right, I hope this is clear. Now our F1 being the frequency of the modal class, we can see it here as 20. Our F0 is the frequency before the modal class, and we don't have a class before the modal class. So our F0 here is going to be 0, right? It's going to be 0. And then our F2 is the frequency after the modal class, and if we check after the modal class, we have a frequency of 12. All right, awesome. So we're just going to put up this table again, and then the next thing we want to do is to put up all these our values. All right, we have L is equals to 7.95, H is equals to 0.9, F1 we said it was 20, F0 is 0, all right, and then F2 is 12. Okay, so we put up our formula again for the mode, and we just plug in all these values. 7.95 plus 0.9 into 20 minus 0 all over 20 minus 0 minus 12 minus 20. All right, and then we put in all these values and we're going to get 8.59. Remember, we said our mode was going to fall in between 8 to 8.9, and we're having the value of 8.59, approximately 8.6 grams per DL. Always write your values. So this is really interesting. Okay, so we have our mean as 10.26, we have our median as 10.00, and now we have our mode as 8.6. This is awesome. All right, our mean hemoglobin concentration for the 66 individuals was 10.26 grams per DL. The median was 10.00 grams per DL, and the mode was 8.6 grams per DL. Well, I would like to close by asking a very simple question. All right, which is the best measure of center to use to represent this data? All right, which is the best measure of center for representation of this data? All right, now if you have gained value in this video, please don't forget to give this video a thumbs up and subscribe to the channel if you have not done so already. Alrighty, in our next video, God willing, we are going to be talking about measures of dispersion. See you in the next video, but until then, peace.